This is a structural account of system failure. It focuses on the distinction between the pre-collapse state of failure and the event of collapse itself.
The analysis proceeds in 6 parts. 1. Defining failure as a precursor state. 2. The sequence of acceleration and feedback compression. 3. Articulating system limits through bounds and recovery bandwidth. 4. Redefining collapse as a system interrupt. 5. Describing the post-interrupt integration phase. The explainer will conclude with a structural implication.
Section 1 defines precursor states, establishing the principle that failure precedes collapse.
Failure is a pre-collapse condition, defined as a loss of internal orientation. This state represents a loss of positional integrity within the system's operational space. It is not equivalent to a loss of function. Function can persist long after the onset of this internal failure.
Orientation is a purely structural condition. It is a system's capacity to locate its current state relative to its own constraints and available transitions. This is a positional property, distinct from narrative, awareness, or data retention.
Section 2 addresses the onset of disorientation through the sequence of acceleration and feedback compression. A specific structural sequence degrades orientation. Sustained acceleration reduces the opportunity for state assessment. Concurrently, feedback compression occurs, as signals that support self-location are delayed, truncated, or overridden. The sequence culminates in orientation blindness, a condition where the system can no longer reliably detect its own degradation.
This condition is also termed momentum blindness. It occurs when a system's internal observation mechanisms become dominated by ongoing motion. The capacity for reflective assessment for checking its position relative to constraints diminishes, even as functionality appears intact.
Section 3 articulates system limits by defining 2 concepts, bounds and recovery bandwidth.
Bounds are empirically inferred admissibility regions. Together, they constitute a control boundary that separates admissible system motion from not admissible motion. They are primary design objects that determine which forms of system behavior are viable. A distinction is required between balance and stability. Balance is defined as the maintenance of system motion within admissible bounds. It requires only containment. Stability, in contrast, concerns the return to a particular state after a disturbance, privileging equilibrium. A system can exhibit balance without stability, and the 2 conditions are not equivalent.
Recovery bandwidth is a bounded property of corrective responsiveness. It defines the maximum rate and extent to which a system can absorb disturbance and correct deviation while maintaining coherent operation. It is a specific, not an infinite capacity.
Section 4 redefines collapse not as a terminal event, but as a non-terminal system interrupt.
Collapse, in this framework, is a non-terminal, internally generated system interrupt. It occurs when accumulated momentum surpasses the system's recovery bandwidth. It's a structural discontinuity that halts destabilizing motion, not a final cessation of function. This definition contrasts with conventional interpretations. Collapse is presented as a structural pause, not a terminal cessation of function. It marks a moment where internal dynamics exceed regulatory limits, rather than representing an error or pathology.
Section 5 describes the integration phase and its post-interrupt dynamics.
Following the interruptive collapse, a system enters an integration phase. This is a distinct and fragile period of nonlinear reassembly. Coherence is reestablished under altered, not restored, constraints. This phase is distinct from recovery or growth.
The integration phase has 5 key properties. The system state is non-reversible. There is a heightened structural sensitivity to perturbation. Reassembly is nonlinear and uneven. The process is one of reconfiguration, not restoration, and the bounds of admissible motion are redefined.
Section 6 presents a structural implication and a final observation from this framework.
A governance implication follows. The evaluation of any design decision should be ordered. Its primary effect on the admissible state space must be considered first. Its contribution to efficiency or output should only be considered secondarily. This prioritizes structural containment over performance metrics.
The final structural observation is this: collapse is not a failure of resilience. It is a signal that a phase boundary has been crossed, separating one qualitatively distinct system state from another. It is a transition, not an endpoint.